Hello everyone. Today let's solve the problem Fedor and new game. Right. So this was asked in the Codeforces around 267 division 2. Right. So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So what the question states here, just give me a second, 1 second. Yeah. In the game Call of Soldiers 3, there are M plus 1 players. There are M plus 1 soldiers, right? So in the game Call of Soldiers 3, there are M plus 1 players and N type of soldiers. N types of soldiers. M plus 1 players and N types of soldiers. N types of soldiers. Each player's army is represented by an integer. Each player's army is represented by an integer where each bit is set to 1. Each player's army is represented by integer where each bit is set to 1. That indicates a soldier type they own. That indicates the soldier type they own, right? Fedor is the last player. Fedor, so here I can just tell you, Fedor is the last player. Fedor is the last player. Just keep this in mind. Fedor is the last player. He wants to be friends with the players whose armies differ in utmost k soldier types. Whose armies differ in utmost k soldier types means bits differ in utmost k positions. Bits differ in utmost k positions. We need to count how many players from the first time I'm speaking, right? We need to count how many players can be Fedor's friend. We need to count how many players can be Fedor's friend, right? So this is it for the question. Basically what we need to find how many players from the first m, basically from the first m, can be Fedor's friend, right? Can be Fedor's friend. So that's what we need to find here. So let me delete this one entirely. I hope the question part is completely clear, man. So this here input, this is nothing but n, and this is nothing but m here. N means this one, what do we call, types of soldier. We have been given 7, 3, the second one 3, whatever I have pointed to. So this is nothing but m is nothing but in the game Call of Soldiers there are m plus 1 players they have given, right? So that we are representing by uh, that is represented by m, and here the value they have given is 3, right? And here this is nothing but the k. This is nothing but k here. Means they have given in the question that Fedor is the last player. He wants to be friends with the players whose armies differ in at most k soldier types. At most k soldier types means bits differ in at most k positions. In the form of bits, or yeah, in the form of bits, we can consider like this: bits differ in at most k positions, right? Fedor is the last player. He wants to be friends with the players whose armies differ in at most k soldier types. So that's what they have given. So this is nothing but k here. So this is nothing but k here, right? So this part, and these are the values: 8, 5, 111 and 17. 7 is nothing but the Fedor. So the last value is nothing but the Fedor value, right? So this is nothing but the, these are nothing but the armies: 8, 5, 111, 111, and this one 17. So this one is nothing but the Fedor army. 17 they have given, right? So this one is nothing but the Fedor army, or Fedor, the last one. So the output that we need to get here is 0, because Fedor cannot be friends with any players whose armies differ in uh, at most k soldier types here in this case. So we have got the answer 0. This one we'll be discussing in the approach clearly. So no worries about that. Don't worry about that for now, right? So for the second one as well, the same thing. So these three NMK. So NMK, these are the armies. These are the armies, and the last value 4 is nothing but the Fedor army, or you can consider as Fedor, right? So I'll just, you can call this one as Fedor army, and we have to get the output 3 here for this one. So I hope the question part is completely clear along with the input part, right? So we will be discussing the approach followed by the complexities, and then let's write the code. Now let's discuss the approach first. So I'll be considering this first example for the approach, right? So you can just try to do the same thing for the try to implement the same thing for the example 2 by considering example 2. I insist you to try out with the for the example 2 basically. So I'll be showing for the example 1. So don't just blindly follow it, rather go for the example 2 and try to implement the same thing that we discussed for the example 1 in the approach, right? So as usual, let's discuss the approach first. So here I have considered the same first example that they have given in the question. So we have n 7 m 3 and k equals 1, and these are the, this is nothing but the army and this is nothing but the Fedor, the last one, right? So output that we need to get here is 0. So one thing, we will be going with the bit manipulation approach. We will be going with the bit manipulation approach, or bitwise XOR, or bitwise XOR, right? So we'll be going with the bit manipulation or the bitwise XOR, right? So here let's move on with the step-by-step explanation. Same thing, n equals 7, the same input we are considering, right? Arm is 8 7 11 1 1 1 17, and Fedor's arm is the last one, the last value, nothing but the 17 here. We will convert Fedor's army to the binary. In the binary, 17 can be written in this way: 1 0 0 0 1. You can just Google it, this one to binary, number 17 to binary, so you'll get this number, right? So we will be considering, I mean, we will be converting this one to the binary. So this one will be 1 0 0 0 1, right? So now we will compare the Fedor's army with each of the first three players. So we have converted this one to the binary, and we will compare that binary number with these three values: 8 5 11, 8 5 11, using the XOR. As I have said, we will be going with the XOR approach, bitwise XOR approach, right? So here, why we are making use of the XOR? XOR gives bits where they differ. XOR gives bits where they differ. So one XOR truth table, if you remember, only if one side of the one, if one side is 1, then only we get 1. Else we have to go with the boolean value, false or 0. So see here, this is the truth table, I believe. So here we have 1 0 0 1 0 0 1 1. So 1 0, we should have 1 at either of the sides. Suppose if we consider a or a and b, so we should have 1 at a or 1 at b, then only the this one result will be 1. So this will be 1, and here we have 1 on the b side, so this will be 1, this will be 0, and this will be 0, because this have both sides 1, this have both sides 0. Either of the side should be 1, then only we will get the value 1 for the this one XOR. Basically here XOR gives the bits where they differ. So we will be counting once using the bit count. We will be counting once using the bit count. If bit count is less than or equal to k, less than or equal to k, then the players can be a friend. See here, k we have been given 1, k we have been given 1. So I'm strictly saying this one: if the bit count is less than or equal to k, then only the player can be that player can be friend, then only that player can be friend. Let's see the same thing for the example that we considered. So this one first, we have 17, we have to compare with 8 5 11. So we have the values 8 5 11 and 17. This is the last value is the Fedor value. So this one we have converted to binary, and now we will be comparing this one with the these three values, right? So now we will compare 17 versus 8, first one. Now we have this one in binary, and 8 we have in binary. So we know the truth table. So only either of the side should be, side should be 1, then only the value will be 1, else the value will be 0. Here 0 1 it will be 1, 0 0 it will be 0, again 0 0 it will be 0, 1 0 it will be 1, 0 1 it will be 1. So the value is double 1 double 0 1. So the number of set bits here is 1 2 3, and k we have is 1. K we have 1. Set bits has to be less than or equal to k, accordingly with the criteria, or accordingly with the approach that we have discussed here. Bit count has to be less than or equal to k. K we have got 1 in the question. See here, they have given k equals 1, n7 m3 k equals 1, right? So this has to be less, set bit count has to be less than or equal to 1, but we have set bits here, sorry, we have set bits here 1 2 3, the number of ones, right? The number of ones. 3 is 3 less than or equal to 1? No, this miserably fails, right? So this guy, the 8 guy, or the first guy with the value 8 cannot be friends. So cannot be friends here. So let's compare the same thing with the 5. 17 versus 5. 17 same thing. 5 we have 00101 here. 00101. So here 1 1 will be 0. I only either of the values has to be 1. Only either of the values has to be 1. Double 1 will lead to the result 0 itself, right? So 1 1 0 0 0 0 1 0 will lead to 1 0 0 again 0. This one 0 and 1 will lead to 1. So we will get the value this one. Now count the set bits, number of ones. We have two ones here. We have two ones here, right? So we have two ones here. Means here k we have 1 and we will check whether 2 is less than or equal to 1. 2 is less than or equal to no. 2 is greater than 1, right? So here in this case, this also fails. The second guy with the value 5, this guy also fails. Basically, he cannot be a friend. He cannot be a friend to the Fedor, right? So he cannot be a friend to the Fedor. The final value is 11 here. So we will compare 17 with the not 11, basically 111, 111, right? So here 17, this one, 111, 111 in the binary is this one. So we will get the output this one. We will get when we perform XOR operations. So you can just check here. 1 1 will lead to 0, 1 0. This one will be 1 1 1 1 because 1 0 0. Three zeros we have and three ones we have in a row. So this will lead to triple one, and again 0 1 will be 1 itself, and the last one we don't have anything, we'll be considering 0, right? So this one will be 1 itself. 1 0 double 1 double 1 0. So output will be this one mainly, right? So the output will be this one mainly. So here k we have is 1 and a set bit or the bit count here, bit count or the set bit here 1 2 3 4 5. This is bit count is 5. 5 is less than or equal to 1? No. 5 is not less than or equal to 1. 5 is greater than 1. So this one also cannot be a friend. So this guy with the value 111 cannot be a friend to Fedor. So nobody can be friends with the Fedor. Currently nobody can be, for this particular example, nobody can be friends with the Fedor. So the output that we got here is 0. So we will return output as 0 because nobody can be friends with the Fedor, right? So I insist you to try out for the second example that they have given in the question. So you will get three friends. You will get three friends because they have given the k value more. Because they have given the k value more, you will get the value 3. So I insist you to try out in the same way that I showed for the example one. You consider the example 2 instead of example one. Try it out in the same way, right? So here we have got the output 0, which is equivalent to the output that they have given for the example 1 in the question, which is equivalent to the output that they have given for the example 1 in the question. So our approach works absolutely correct in this case. As we are completely familiar with the approach, let's move on with the complexities part. Let's move on with the complexities part. So what would be the time complexity here? The time complexity would be big of m. So why it is big of m here? We will be looping through m players. This one I'm speaking of. We will be looping through m players and do constant time operations for each So here the time complexity would be big of m. What would be the space complexity here? The space complexity would be big of m as well. The space complexity would be big of m as well because we will be storing m plus 1 integers, right? In the question itself they have mentioned, right? In the question itself they have mentioned it will come with m plus 1 integers, right? So we will be storing m plus 1 integers or the arrays and will not be making use of any extra space here. So the space complexity would lead to big of m, and the time complexity would lead to big of m as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m respectively for both, right? So now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code. Now let's start writing the code. I'll just come to the compiler here. So here first thing is we will be making use of the different utilities. So I'll just import the utility package here. So I'll just go with java.util.star. So this is fine. Let me go with the class name here. Let's create the class. So I'll just name this one main. You can just give the question name or anything that is relevant to the question, right? So I'll just go with a main. So this is fine. We don't have to make use of input output exception, I think, for this. This is fine. Yeah. I'll just make use of the scanner. We don't have to go with the buffer header and the print writer. I'll just go with the scanner for this particular question. So this is enough. So this one will be new scanner. So I'll just go with system dot in. This is fine. So let me come out of, let's move on with the further things. So first we will be going with the NMK, if you remember in the input, right? So we have to go with the total soldier types, total number of other players, also max allowed different bits, nothing but the Hamming distance K, right? Hamming distance K. First, let's go with the total soldier types, nothing but N here. So I'll just go with int N equals scanner dot, uh, this is represented in the form of int, right? So I'll just go with the next int. I have to read this one, right? Just go with the scanner. So let me copy the same thing for m and k. So this one will be m, this one will be k. So this is fine. So let me make this one m, and also let me make this one k, and also let me make this one k. So this one, first one, the line number 7, this is for the total soldier types, and the line number 8, this is for the total number of other players, and the last one is max allowed different bits, nothing but the Hamming distance. So I'll just, let's move on with the further types. So we have to store all the m players plus Fedor's army, right? We have to store all the m players plus Fedor's army because we have to compare them, right? So we have to convert that one to the binary, or we have to perform XOR operations, right? So for that one, we have to store all the m players plus Fedor's army. The last one, basically we have to store all the m players, nothing but m plus 1 plus Fedor's army, nothing but m plus 1 here. So I can write in this way, int. So this one will be players new int of m plus 1, new int of m plus 1. Let's move on with the for loop here, iteration part. So this one will be I equals 0, I less than, so we have considered m here, right? So yeah, I less than or equal to m. So let me increment the I. So within the for loop, we have to read each army, right? So this will be players, iterated value of the players. Let me assign this one to scanner dot next int. So this is fine. So let me come out of this one entirely. We come out of this one entirely. So let's go with the last entry, that is Fedor's army. So I can just write this one in this way. This one I can just go with Fedor's army, Fedor's army. So I'll just go with Fedor's army. So this one equals players of m, players of m. This is fine. And also let me initialize count to 0, and also let me initialize count to 0. Let's go with the uh, one more iteration here. Let's go with the one more iteration because we have initialized the last entry in the Fedor's army, nothing but Fedor's army equals players of m, whatever I have given. And also I have initialized count of players who can be Fedor's friend, nothing but count to 0. Now I'm going with the iteration because we have to perform XOR to find the different bits. So accordingly with the approach, we have to go with the XOR. We have to perform the XOR to find the different bits, right? So we have to count the bits. Basically, we have to count the bits, set bits, right? If it is greater, if it is greater than k, then he cannot be a friend. Then that guy cannot be a friend. If it is less than or equal to k, then only the guy can be a friend of the Fedor, Fedor or the Fedor army, right? So for that one, I'll be going with the iteration. So this will be for int I equals 0, I less than m. This will be I plus plus. So here, within the for loop, we will be performing XOR to find different bits. So here this will be XOR equals uh, Fedor's army. So this will be, we are performing the XOR, right? So this will be players of I. So this is fine, players of I. The next one is if differing bits is less than or equal to k, then only we will count as a friend. This one we have discussed in the approach. Same thing we are articulating in the form of code. If the differing bits or the if set bits or the if bit count is less than or equal to k, then only we will count that guy as a friend, or else we will not consider that guy as a friend, right? So let's write the simple if condition for that. So I'll just go with integer dot bit count here of XOR. We have considered XOR here, right? XOR, if it is less than or equal to k, then we will increment the count. Initially we have set the count to 0, right? Then only we will increment the count. If it is greater than k, in our case, Nobody means we compared with 8, 5 and 111 with the 17 Fedor's army. So every guy had the set bit I mean bit count or the set bits greater than k. So for the first example nobody could be friends with the Fedor. For the first example nobody could be friends with the Fedor, right? So the answer that we got was 0 if the value we got was less than or equal to k. Value we got was less than or equal to k, then we would increment the count here. I hope this part is completely clear, man. Very easy to understand, right? So I'll just come out of this one entirely. So finally what we have to do, we have to output the total number of friends. We have to output the total number of friends. As we have made use of the scanner, I'll just go with the this one, system out println here. So here I'll give count. So this one, let me give count here. So yeah, this is it for the code. Right? So before checking this one with the, what do we call, yeah, before checking this one with the different inputs, I just want to copy paste the signature starter template. Just give me a second. Let me make this small. Yeah. So I'll just come here. Just give me a second. Yeah. This is actually the easy one. Right? So I'll just let's try this one with the different inputs first. So we have to get the output 0 for the first input. Let me run this one. Mm, main error class interface enum or record expected. What is wrong here? So public class main, what is wrong? So I have to give p small here, right? Just give me a second one. Yeah, let me run this one now. Yeah, we are getting the output 0, right? So now let's try with a different input. So we have to get the output 3 here for this one. Paste this one and let me run here. Yeah, we are getting the output 3 here, right? We are getting the output 3. So our code works absolutely correct in this case. Our code works absolutely correct for all the examples or the inputs that they have given in the question. So let me copy this one. And let me paste it over here. And let me hit the submit button. So let's wait for some time. You can clearly see here running on test one, right? So here you can clearly see whatever the code that we have written got accepted. Means the verdict it is showing accepted here, right? So whatever the code that we have written works absolutely correct for all the test cases. Basically, we have went with a bitwise XOR or bit manipulation approach, right? So we have made use of the XOR here somewhere. Just give me a second. This one. XOR is equal to Fedor's army, XOR players I. We have to count the set bits basically, right? So we have to go with the bit count. That is the reason we are making use of the XOR here. Main thing is we are making use of XOR here, right? So I hope the solution part is completely clear along with the approach and the complexities part. For now, this is it. Thanks for watching, guys.